You know, in the world of AI, the story we hear over and over is that bigger is always better, right? More data, more parameters, more raw power. But what if? What if, for some of the absolute hardest problems out there, the complete opposite is true? Well, today we're going to dive into this incredible story of how one tiny model is taking on and beating the AI giants.
I mean, it sounds kind of crazy, doesn't it? Can a tiny little AI really outperform models that are like 1,000 times its size? How could something that's just a tiny fraction of today's giant models even stand a chance, let alone actually win? That's the big question we're going to get to the bottom of.
And look, this really puts the scale of the challenge into perspective. On one hand, you've got your massive large language models with, 671 billion parameters. And on the other, our little guy, the Tiny Recursive Model, with just 7 million. This is the definition of a David and Goliath matchup in the world of AI.
Okay, so to really get why this tiny model even has a shot, we first need to understand where the giants, where they falter. We gotta look at the limits of these huge large language models, or LLMs as we all know.
So here's the Achilles heel for these big models. They build their answers one piece at a time, token by token. Now imagine you're solving a super complex puzzle. If you make one wrong move at the very beginning, the whole thing just falls apart. That's the problem LLMs face. And even with fancy techniques like chain of thought, their reasoning can be really fragile and super expensive to run. The proof? Look at Gemini 2.5 Pro, one of the best out there, scoring less than 5% on a major reasoning test. That's not great.
All right, so clearly a new path was needed. Researchers knew they had to try something different, and that led them to their first attempt at cracking this nut, a model called the Hierarchical Reasoning Model, or HRM for short.
The whole idea behind HRM was pretty cool and actually inspired by the human brain. Instead of one giant network, it used two smaller, separate ones that would kind of talk to each other. They'd pass information back and forth, tweaking and refining the answer over time. Think of it like how different parts of your brain work together, some fast, some slow, to solve a problem.
So here's how it worked. You had one network, FL, that was just buzzing along at high speed, dealing with all the nitty-gritty details. Then you had the second network, FH, taking its time, looking at the big picture. And the magic was supposed to happen when they fed their outputs back into each other over and over again until they landed on an answer. It's a clever idea for sure, but it was also really complicated.
And yeah, that complexity turned out to be its biggest weakness. So while HRM was definitely a step in the right direction, the real breakthrough didn't come from adding more stuff. It came from stripping things away.
And you don't have to take my word for it. The researchers themselves basically said, hey, HIM is leaning a bit too hard on some shaky biological ideas and math theorems that we can't even be sure apply here. Basically, its foundations were complex and, frankly, a bit wobbly. It was kind of a black box.
This is where things get really interesting. The next team of researchers looked at HRM and just started simplifying. They got rid of the whole two-network system. They tossed out that complicated math shortcut. The vague brain analogies, gone. And that clunky, inefficient training process, see ya. It was a classic case of addition by subtraction.
And what was left after all that trimming? Well, that's the star of the show today, the Tiny Recursive Model, or TRM. And this is where the story gets really good, because it's all about elegance and pure efficiency.
Now this is the brilliant conceptual leap they made. They took HRM's two confusing, abstract features and reimagined them into something super intuitive. They said, okay, Z is now just our scratch pad. That's where the model does all its rough work. And why? That's the answer that it's trying to refine. Suddenly it all makes sense. It's not some weird hierarchy, it's just a workspace and a final answer.
And when I say simple, I mean it is shockingly simple. Get this, the entire neural network has just 2 layers. 2. In an age where we're talking about models with hundreds of layers, that is just wild. But what they found was that for these kinds of reasoning puzzles, adding more layers actually made things worse. The model would just overfit. So in this case, less wasn't just more, it was everything.
So let's just recap the key innovations here, because this is the secret sauce. First, one single network instead of 2, which immediately cuts the parameters in half. Second, they got rid of the math shortcut and went back to good old-fashioned backpropagation, the core way these networks learn. And boom, accuracy shot way up. They also made the training way more efficient. And finally, they use a smart trick called EMA to keep the model stable and prevent it from getting confused by the small amount of training data. Every single one of these choices made TRM smaller, faster, and just plain better.
All right,
So theory is great. We have a smaller, simpler, way more elegant model. But the big question is, does it actually work? It's time for the moment of truth. Let's look at the results.
And wow, just look at this table. It says it all. For super hard Sudoku and maze puzzles, the giant LLMs, they get a big fat 0. Can't solve them. HRM, the model that came before, does okay. 55, 74%. Not bad. But then look at TRM. Our tiny little model is hitting nearly 88% on extreme Sudoku. That's not just a little bit better, it's in a completely different league.
And the winning streak doesn't stop there. On the ARC-AGI benchmark, which is all about testing true abstract reasoning, it's the same story. TRM clearly pulls ahead of the more complicated HRM model. The advantage is undeniable.
Then they threw the even harder version of that test at it, ARC-AGI 2. And again, TRM widens its lead. Now, I know 5% versus almost 8% might not sound like a huge jump, but trust me, in the world of cutting-edge AI reasoning, that is a massive improvement, especially for a model that's a fraction of the size.
So what does this all mean? Why does this matter so much? Well, for one, it completely flips the bigger is always better script we've been hearing in AI for years. It's proof that for certain types of problems, an elegant, efficient design can absolutely crush brute force scale. It shows that sometimes the smartest move is to simplify, not complicate. And honestly, it points to a whole new, exciting direction for AI research, one that isn't just about a race to build the biggest model on the planet.
And that really leaves us with a huge, fascinating question. If less is more works so well for reasoning, what's next? What other massive AI problems, currently dominated by these giant models, are just waiting for a tiny, elegant solution to come along and completely change the game? It really feels like the age of the tiny giants might just be getting started.